So on this review for number 1, we're going to look at it. We see that there's 2 radicals, and to solve these square root problems or radical problems, we want to isolate one of the radicals. So what I'm going to do is I'm going to isolate the more complex looking one, the x minus 28, and then I'm going to move the radical x over to the other side. So it's going to equal 2 minus radical x. Now to get rid of the radical on the left side, I'm going to square it, so I have to do the same thing to the expression on the right. By squaring the square root, what basically it does is it isolates that, it cancels out the radical and it leaves the x minus 28. And on the other side, I'm going to have to FOIL. Okay, so I'm going to have to FOIL the expression, or multiply 2 minus radical x times 2 minus radical x. So I'm going to get 4 minus 2 radical x. When I do inner, I get minus 2 radical x again, and when I do last times last, I get plus x. I'm going to combine the like terms on that right side. So it's going to be 4 minus 4 radical x plus x. And there's no other like terms, so what I want to do at this point is I want to isolate the radical that's on the right side. So I'll start by subtracting 4 from both sides, and I'll subtract x from both sides. That'll leave me with minus 4 radical x on the right, and it'll leave me with minus 32 on the left. Last thing I'm going to do before I get to that radical x is try to get it isolated. I'm going to divide both sides by minus 4, and I'm going to get radical x equals 8. So again, I don't want to know what radical x equals, I want to know what x equals. So I'm going to have to square that. So I do the same thing to the left. 8 squared is 64. So 64 equals x, or x equals 64. Now, I have to check this answer, because I always have to check answers when there are variables in the denominator or when it's in a radical. And so here, I'm going to substitute in 64 wherever there's an x. And I'm going to see if that ends up equaling 0. So this is radical 36 equals 2, or not 0, but equals 2. And then I get 8 plus 6 equals 2, 14 equals 2, and I know that that is false. And because that's false, I know that there's no solution here, because this gets canceled out, and there's nothing left. So this is a no solution. When I get to number 2, it's the same concept. Instead of being in radical form, it's a fractional exponent. So what I'm going to do is I'm going to want to raise it to the reciprocal power. So I'm going to want to raise it to the 3/2 power, and I'm going to do the same thing here to the 3/2 power. Because the denominator of the fraction that I raised it to is a 2, I know that I'm going to have to do a plus minus here for this. Okay, so on the left side, this 2/3 times 3/2 is going to become 1, so it's just going to be x plus 3 to the 1 power, which is itself. And it's going to be plus minus 25 to the 3/2 power. Well, that's going to be the square root of 25 cubed. So x plus 3 is on the left. On the right side, I'm going to get the square root of 25, which I can do is just 5. And then I have 5 cubed. And it's positive or negative 5 cubed, so x plus 3 equals plus minus 125, and then I subtract 3 from both sides. So what I'm going to get is x equals negative 3 plus or minus 125. So negative 3 plus 125 is 122, and negative 3 minus 125 is minus 128. And so I have 2 solutions here, and I do in fact need to check them to see if they work. So when I come over to the checking part here, I'm going to check. What I'm going to do is I'm going to start with 122 plus 3 to the 2/3 power equals 25. 125 to the 2/3 power equals 25. I know this is the cube root of 125. Squared is 25. Cube root is 5, so 5 squared is 25. 25 equals 25, and it works. And now I'm going to do the same thing with negative 128. So again, it's negative 128 plus 3 to the 2/3 power is 25. Negative 125 to the 2/3 power is 25. Again, the cube root of negative 125 squared is 25. Negative 5 squared is 25. And 25 is 25. And so when we check it, they both work, and so both of these solutions are valid. We go over to the next one, and again, we're in the same situation. We have those two radicals. Now, I could square both sides as they are, but for me personally, I think it's easier to, when I have to square an expression, instead of squaring that one, which I don't really like the looks of that, I'd rather subtract 1 from both sides, like that. I'd rather get the x minus 3, the radical x minus 3 on the left, and I'd rather get radical x minus 1 on the right. Now I'd like to square this one and square this one, just because I think the math is a little easier. Either way, you'll get the same answer. So this side's just going to be x minus 3, and again, this is going to be square root of x minus 1 times the square root of x minus 1. So I'm going to FOIL this. So square root of x times square root of x is x. Then I'm going to do outer, inner, and last times last. So I keep working on that right side. I'm going to get x minus 2 radical x plus 1. And I know I'm going to subtract x from both sides, and I'm going to subtract 1 from both sides. So I'm going to end up with negative 4 equals negative 2 radical x. I'm going to divide by negative 2. So I'm going to get positive 2 equals radical x, and I'm going to square both sides to free up that x. So I'm going to get x equals 4. So this is my solution, but I still have to check it. So I can go to this one, or I can go to the original. I'd rather plug it into the original, so that's what I'm going to do. So it's going to be square root, I'm going to put 4 minus 3 plus 1 equals square root of 4. So the square root of 1 plus 1 is the square root of 4. This is 1 plus 1 equals 2. 2 equals 2. That works. And so this is a valid solution. Now we get to our first problem with an absolute value. And so absolute values, we know that they can equal two different values. And so whenever you see absolute value, you know you're going to end up, unless it's a special case of like a no solution or an all real solutions, you're going to end up setting up two equations. So you have an absolute value inequality here. Our first step is going to be to isolate the absolute value. So we're going to leave the 7 minus 2x on the left, and we're going to add 4 to both sides. So what I'm going to get is absolute value of 7 minus 2x is less than positive 3. Now that it's isolated, I ask myself, is it reasonable? Is it reasonable to think that the absolute value of something is less than 3? Yes. And so if it's reasonable, I'm going to begin my setup. And what I do is I take this symbol that's here, and I copy it there, and then I do negative 3. So I'm going to write this as negative 3 is less than 7 minus 2x, which is less than positive 3. Because this is a less than, and more so, not so much at this phase, but at this phase when everything is done and isolated, the absolute value is isolated, I know that this is an and scenario. Okay, so I know my solutions are going to be, it's going to be an and it's going to be in between my 2 points, and I'll show you what I mean. I'm going to start solving here. I want to isolate x, so I'm going to start by subtracting 7 from both sides and the center. So I get minus 10 is less than negative 2x, which is less than negative 4. I'm going to divide everything by negative 2. And because I divided by a negative, I'm going to be flipping my signs as well. And I get 2. And so I'm going to rewrite it. Obviously 2 is smaller than 5, so 2 should be on the left. So 2 is less than x, which is less than 5. Okay, and so when I do this on that's my inequality statement. When I do it on a number line, here's 2, here's 5, and I'm going to be doing an open circle at 2, an open circle at 5, and I'm going to be, my solution is everything in between those 2 points. And as an interval notation, it's going to be parentheses 2, comma 5, parentheses. So all 3 of these are valid solution statements. They're just different forms. Inequality statement, interval notation, and a graph. Okay, so now we're going to keep going here. I'm going to move the paper. I don't know what's happening here. But we're going to focus on number 5 right now. And we see that we have absolute value inequality. Again, before we make any decisions as to even how to begin, we're going to isolate the absolute value. So we're going to divide the absolute value by 3. We divide both sides by 3. That's going to eliminate that. It's going to leave the absolute value of x plus 11 isolated on the left side, and then we're going to have is greater than or equal to negative 3. And so again, now we ask ourselves, is it reasonable to think that it would be greater than or equal to negative 3? Yes. At what values is it greater than or equal to 3? At any value. It's at any x value. In other words, it's always going to be an absolute value of anything is always going to be greater than a negative number. And so this is an all real solutions, or in terms of interval notation, it's going to be negative infinity to positive infinity. So we can keep going now to number 6. And number 6, we can solve this 2 ways. We can look at this and say, well, if I just make this x squared equals 16, I can do like I did with square root method. Square root of the left plus minus square root of the right, x equals plus minus 4. So my key values are positive and negative 4. So negative 4, positive 4, 0 is in between these. And so what I'm going to do is I'm going to test the sector with 0 in it. 0 squared is less than 16. 0 is less than 16. That's true. And so I know this is a solution sector, so this sector is not, and the one on the right is not, because they alternate. So I know my solution. I'm going to do an open circle at negative 4, an open circle at positive 4, and my solution is in between those two. As an interval notation, it's negative 4 to 4 with parentheses. Now, because again, we've been sort of setting everything equal to 0, another way to do this problem, if you did not use square roots, would just be to do x squared minus 16 is less than, or not equal to, sorry, is less than 0, and then do x squared minus 16 equals 0. So x plus 4 and x minus 4 if we factor it, and we're still going to get x is negative 4 and x is positive 4. But it's just a different way to get there. So either way would work, okay? If we come over to here, to x plus 3 squared is less than or equal to 16, again, we could do our square root method. We could come here and do x plus 3 squared equals 16, square root plus minus square root, x plus 3 equals positive and negative 4, and then we subtract 3 from both sides. And so I know that that's going to be negative 3 plus 4, which is 1, and it's going to be negative 3 minus 4, which is negative 7. Those would be my key points. And so again, I'd come over here, I'd have negative 7, positive 1, I would find 0, what sector is 0 in? 0 is there. And so I can then come back and check it. So I can plug 0 in for x and determine if it's a true statement or not. So 3 squared is less than or equal to 16. 9 is less than or equal to 16. That's true. So the sector with 0 in it is valid. That means the one to its left and the one to its right is not. Now, because this original problem was a less than or equal to, my key points are going to be solid circles this time. And I'm going to shade in between. As an interval notation, it'll get a bracket, negative 7 to 1, and another bracket. So the square root method works. Now again, if I didn't want to do the square root method, I could actually solve it a little bit longer. I would have to FOIL this side. Be x squared plus 6x plus 9 is less than or equal to 16. I could then move 16 over to the left side by subtracting it, so I'd get minus 7. And then I would do, this is x plus 7, x minus 1 equals 0. So x is negative 7, and x is 1. And I could get my key points like that. So either the square root method or the factoring method is fine. Both Okay, now we go to number 8. Now this one's a little bit different. This is a rational inequality, and so, or inequality involving rational expressions. And this one, I don't remember seeing any examples of this in my slides when I taught my students this. So again, this one's a little bit different. So what initially when we see this, we might think, well, hey, I'm just going to multiply both sides by x minus 1. And what that's going to do is it's going to get rid of my denominator. The sad part is, or the bad part about this is that I can't do that. Because if I multiply by x minus 1 here, and I multiply by x minus 1 here, I don't know what to do with that sign, because I don't really know if x minus 1 is positive or negative. And so we can't do that with an inequality as much as we'd like to. We can do it with equations, but we can't do it with inequalities. So the trick to that is to set it all equal to 0. So what I'm going to do is I'm going to have to take the 3x plus 7 over x minus 1 and subtract 2 from it, and make the right side equal to 0. Now what I want to do is I want to get all of this under one fraction. So I'm going to multiply both of these terms by x minus 1. Now again, I can't do it to both sides of the equation, so all I could do is simplify the left side. This will cancel, leaving me with 3x plus 7, and then it's minus 2 times x minus 1. And it'll all be over x minus 1. I can't eliminate the denominator because, or the LCD, because again, I didn't do it to both sides of the inequality or the equation. So it's still going to be greater than or equal to 0. I'm going to distribute at the top the minus 2 to the x minus 1. And over x minus 1, still greater than or equal to 0. And I'm going to combine those like terms at the top. So x plus 9 over x minus 1 and is greater than or equal to 0. So now what I have to do is I basically set, when I have this final fraction and I have the 0 on the right side, is now I'm going to set my numerator equal to 0. So I'm going to do x plus 9 equals 0, so x equals negative 9. I'm going to set my denominator equal to 0, x minus 1 equals 0, so x is 1. So these become my key points. So I come back over to our sectors that we're used to creating. I'm going to get a minus 9, and I'm going to get a positive 1. And so, again, I'm sort of creating those same sectors, okay? 0 is here, so I'm going to plug 0 in, but it's a little bit weird because I'm plugging 0 in to the expression. So if I come to the thing and I do 0 plus 9 over x over 0 minus 1, is it greater than or equal to 0? I could do it there, and or if not, I could even do it to the original. In fact, let me do that. I'm going to plug it into the original equation better than that. So it's going to be 3 times 0 plus 7 over 0 minus 1 is greater than or equal to 2. So 7 over negative 1 is greater than or equal to 2. So negative 7 is never going to be greater than or equal to positive 2. And so this is not a solution set. So I know my solutions are here and here. So what I need to figure out now is my shading, right? I need to know, is it an open circle or a closed circle? And initially, again, this would be a no-brainer. This would be a closed circle. But because there's a denominator, it's tricky. So if I go back to when I factored it, negative 9 referred to the numerator value, and negative 9 plus 9 is 0, but my denominator, or my numerator, can be 0. It's okay to be 0, so it can include negative 9. So it's a closed circle, and it goes this way. Now when I go the other one, when I look at this key value, I know x is 1 makes my denominator 0. Can my denominator be equal to 0? The answer is no, right? So this one has to be an open circle because it includes everything to the right of 1, all the values greater than 1, but it just can't include 1 because 1 would make my denominator equal to 0. So this one's really kind of tricky. Negative infinity to 9 with a bracket, and then 1 to positive infinity with parentheses. And so that would be the interval notation for that solution. Last two questions. We're going to come here and we're raising this to the 2/5 power, and the expression on the right is the 1/5 power. What I would do, since the denominators are the same, I would just raise, and the numerators are not the same, so the reciprocal might complicate it. I'm just going to raise everything to the least common denominator of the denominators, right? So it would be 5, right? So I'm going to do 2/5 times 5, and that's going to leave me with x minus 2 squared. And on the other side, I'm going to do 1/5 times 5, and that's going to leave me with x to the 1. Okay, so x minus 2 squared is x squared minus 4x plus 4 equals x. And I'm going to subtract x from both sides. So minus 5x plus 4 equals 0. Now I'm going to factor. And I get that x is 4 and x is 1. So those are my solutions to this problem. I would check for extraneous. Usually when you have a fifth root, you don't have to check for extraneous. And if you're raising it to something maybe, but they're both going to be good. You can try them. You'll see that they both work. And then the last but not least, this one, we have an absolute value inequality. Again, I've got to first isolate it, so I'm going to have to divide both sides by -2. So I'm going to get absolute value of x minus 1 is less than or equal to -5. And now that it's isolated, I ask myself, is it reasonable? Is it reasonable to assume that the absolute value of something is going to be less than or equal to a negative number? No, it's never going to be less than or equal to a negative number. And so since it's not going to be equal to it, this is a no solution. It's never going to happen, so no solution. And that's it, guys. That's the video. And you could, if I came back